Let's take a closer look at web application threats. You're going to need to be able to identify these. Whether you take the exam or not, you need to recognize these when you see them. There are loads of threats to web apps. We know about most of these already. We could poison or compromise a cookie. The user's private data or their keys or whatever are not stored properly. It's insecure. There is leakage of information. There are broken accounts and they're not managed properly. There's improper handling of errors. There's us tampering with forms and parameters. There's directory traversal and denial of service and buffer overflows. We could tamper with server logs. We could try to put in unvalidated input, so we're injecting commands. Maybe there's access control that is broken. Maybe the security is misconfigured. Maybe the session management isn't good. Maybe we have broken sessions. We could have SQL injection and the cross-site, the scripting, and the forgery. There could be just general injection flaws. There could be exploits against the platform itself, or references to insecure direct objects, or insufficient transport layer protections, or the inability to restrict access to URLs, or cryptographic storage is not secure, or we have applications that obfuscate, that hide themselves. They're not scannable, or they're not recognizable, rather, in a scan. We could have attacks in the DMZ. We could have exploits against security management, and we can authenticate or hijack authentication, or we could redirect or forward to unvalidated locations, or we could have session fixation, or attacks against CAPTCHAs, which are supposed to prove that it's a human and not an automated process. We could sniff or snoop cookies. We could attack network access or manipulate things behind the scenes and attack the web services in general. Unvalidated input, this is like one of the biggest things. This is where the web app was written hastily, not carefully, with not good coding, so that input from the client is not checked before it is actually sent to the web server. So we, as attackers, we take advantage of the lack of input validation or poor input validation to inject malicious commands alongside or in place of normal requests, which then cause whatever the attack is. Unicode exploit. Here's an oldie but goodie. So when we talk about obfuscation, meaning we mix things up so you can't tell, Unicode is a 2-byte character set. The whole purpose of Unicode is, once upon a time, there was a character set called ASCII. And originally it was 7 bits was a keyboard stroke. And then they said, which meant you could have 128 possible letters and numbers. And they said, let's extend that to include a few special characters. So now it's 8 bits or a byte. So 1 byte is 1 keyboard character. But that's only 2 to the 8th, which is 256 possible combinations. That's okay for English. That does not cover all the other human languages out there, which use their own character sets, their own alphabets, their own style of writing, everything. So we needed a character set that was able to encompass every possible human written language that there is. And thus Unicode came about. So Unicode can have 65,536 possible characters, which at this point is enough to encompass English, Chinese, Japanese, Korean, Cyrillic, Arabic, the list goes on. And of course, a lot of languages just borrow from those other languages. So the thing about the Unicode exploit, and there were some spectacular virus attacks based on Unicode. Back in Windows 2000, there was the Windows 2000 server, by default, had the web server IIS installed with it in a default install. And IIS had a little folder called scripts. I think it still does. And anything you put, any scripts you put in that folder, IIS would run for you. Well, there was a hacker who realized that if in the URL they included the path to the scripts folder
And then they put in just a couple of Unicode characters, and there were like about a dozen that were discovered, maybe give or take. Then after that, you could just have a pathway to like cmd.exe or any other executable, and you could, from a URL, run an operating system command. It was wild. I mean, you could TFTP, you could change directories, you could replace web files and deface sites, you could steal stuff, you could upload Netcat listeners and have them cut in front of IIS and redirect calls that were coming through a firewall, redirect them to some other process. I mean, it was crazy. And we had some famous viruses, Code Red 2, NIMDA, that exploited this. Believe it or not, the Unicode exploit exists in the wild to today. I don't know if people run automated tools like for decades or something. It's amazing. Anyway, Unicode is really amazing in the way it works and the way it was just exploited. And I mean, it exploded like wildfire back in those days. I just want to show you an example of Unicode here. So I'm going to just some website, and then I just say script, and then I can have these phony characters, these Unicode characters, that actually represent something else. And part of it is, please do a directory traversal. And in this case, go to the Etsy directory inside of root and grab me the password file. So that's just one example of a Unicode exploit. We can tamper with forms and parameters. We can manipulate parameters sent between the server and the client. We can alter application data. This uses vulnerability in the logic validation mechanisms and the integrity mechanisms. So the server sends a client a form. Tell the user to fill out the form. But we're messing with the form in the background. Not using a browser, but using a tool where we can look underneath the hood. So we could tamper with that. Authorization attacks. We could pollute parameters. We could supply multiple instances of the same parameter in one HTTP request. And the app might not properly handle these multiple instances, which would enable us to modify values or trigger valuable errors. Typical GET request example for searching would look something like this. http://test something question mark. The question mark means it's something executable. Search for weather. Okay. Now, what we do is we pollute this request and we add a second search parameter. Search for weather and search for something else. Now, what will happen is that the app is going to ditch the weather part and only keep the second search. So it may return something, it may not. It'll throw out an error. Now, some apps will return the original and then throw out the second one, which in this case is empty. And it'll return valuable error information, which tells us how the whole database is structured. Or, depending on the app, it can ignore the first one, and if the second one has something, it'll only return the second one. So it's really crafty how we can use that. We could use a POST request to sign into a web portal using a security token. So like, for example, HTTP someplace token equals my token, portal ID equals my portal ID. Now, if I could grab this and manipulate this, then I am in control of what the user is doing as they're logging in. Or I'm just going to replay this. They log in, I log in. So we could pollute their authorization request or their authentication with a second portal ID parameter. So go to this thing, here's the token, us, and a portal ID, our attacker ID, and then a portal ID for the victim ID, which means we're using their authentication, but letting us go along for the ride. We can also have something called direct object reference. We can refer to the actual name of something in the system that is used by the application that we're not supposed to know about. We can manipulate parameters that directly reference an object that will grant us access to the objects that we're not supposed to have authorization to. We could have a SQL call. A SQL call might request account info by referencing the account name parameter. What we do is we swap out account name with something different. And then instead of looking here, it grants us access to something else. Maybe another account instead of the first account. Again, like I said, we can do directory traversal. We can gain access to restricted directories. We can execute commands outside of the root directory of the server. If you see .. then that is directory traversal. Sometimes it can be hidden, obfuscated in Unicode, like we saw earlier. So this allows us to access files located outside the web publishing directory, out in the operating system. There could be all sorts of security misconfigurations. Attackers can get unauthorized access to default accounts, read unused pages, read and write unprotected files, exploit unpatched flaws. This could occur at any level of the application stack, like you didn't change any default accounts, or the app server admin console was installed automatically and not removed, or standard admin pages are still there on the server when they shouldn't be. So there are some common web application threats.